And I think we're live, right? Yeah.
Yes.
Hello, everybody.
Yeah, for sure.
Welcome to the live stream. My name is Adam, and I'm joined here with.
Josh, hi. Hello. How's everybody doing?
Yeah. Today we'll be making a variant on this nice, wonderful Chrome dinosaur game that you can play whenever you don't have an internet connection. So simple.
This runner.
Yeah, just a simple endless runner. Unfortunately, neither Josh nor I are artists, so instead of using a dinosaur and a cactus and do miserably, we will be instead doing a blobs, right? Like rectangles and squares and stuff. More like a Geometry Dash style thing.
Yeah, let's go with that.
Yeah. But in order to do this, we're going to use the p5.js library. So if you want to follow along at home, you can go to editor.p5.js.org right here. So, yeah, the first thing we want to do is we want to make our objects where we have a player object, and then I think we wanted to go for like a spike object or something like that.
Mm-hmm.
So we just go ahead and make new files. We want player.js, and then we also want a blob.js right here. And so in our player file, we're gonna start just making a nice simple rectangle. We need class player right here.
This is going to be the setup for an object, right? For the objects that you can use. Okay. Mm-hmm.
Yeah, so we're making a new object. We have our constructor right here. So basically, for those of you guys who are following who don't know what this is, we are telling the computer what a player is. And we're giving it all the instructions. So a player, whenever we make a player, it's this and this. It looks like this. It can do these things. And then we could just make the player in our actual JavaScript file that will be called here. I hope that makes sense.
Yeah, that makes sense.
Yeah. So we need an X coordinate, right?
Yes.
Say that's like 50 units over. We need a Y coordinate. Say that's we want the height of the frame minus the size of it, the player. So it's doing a square. Let's do this dot size equals 50. So that'll be our side length right there, and our Y is height minus this dot size. So the reason why we're doing this is because when I push play, we have our canvas that looks like this, right? And our X coordinate goes from this top corner over to the right, like a normal X coordinate. And our Y coordinate, instead of like on a normal Cartesian plane, it goes up, right? But when you're making programs and stuff, it tends to start from this upper left-hand corner and go down. So we want our player object to rest somewhere around here in this lower region. We're going to go over 50 units, and then we're going to plant the upper left-hand corner at the total height, the Y height, right, minus a little bit. So it'll go from here. It'll be just up a little bit, so that'd be the upper left-hand corner of it, right there.
TT says Pog.
Pog!
And a smiley face.
Yeah, poggers! Woo! Is that the right way to handle this? We really should figure out how to
He says, sorry, I wasn't here last time. I was sick. No worries, man.
Oh, we missed you last time, TT.
We're glad you're here, though.
Yes. Yep. We also need a show function too, right?
Yes, of course. Because then how was it going to show?
Yes. So we just want to make a simple rectangle. So the rectangle takes in two corners of it. So we're going to do the upper left-hand corner, which is our this.x and this.y right here, and in our lower right-hand corner. Or no, excuse me. The rectangle thing I think takes in the beginning coordinates and then the size of it. So it takes in the upper left-hand corner, and then the size, like the side length, the length and the width of it, which just happens to be the same in this case. So it's the size and this dot size right here, just like this. So now we can go here, and under our sketch file, we can make a new player. So we can have a global variable. So you let player right there, and then when we set up the thing, people who aren't familiar with p5.js, like myself and Josh, because we kind of figured all this stuff out this morning. But and that's like a big thing about programming, is that like the logic is the same in a lot of languages, right? The syntax is a little different, but like if you understand like Python, you can easily jump into something like this. And although you have to change something else, like you have to use let to define a new variable instead of just saying the new variable, it's very easy to get a hold of. So the setup function is run whenever the page loads, and this draw function is run every single frame, essentially.
Yes, basically.
Yeah. So setup, we want to say the player equals a new player, something like that. I think we can also do this outside up here as well, right?
I believe so. I believe you
Maybe.
can. Then it'll be global to specific functions, not to that specific function. I believe. It's been a while since I played with JavaScript.
I don't know. Well,
but like I said, most or like you said, I'm sorry. Most programming languages have the same syntax, or at least similar to it. So I'm sure it is the same.
Yes. Also, as you see, I have Grammarly enabled, and it's weird right here.
Wow, that is weird.
So I don't know what's going on. Grammarly does not work with code, but we're calling we're making a new player here. It's like a new player, and then we're calling the player.show method. So it's just going to show the player, right? Which means it's going to draw the rectangle. So when we push run, oh, we got an error. Oh, shoot. We actually have to link our script things. So just like any other HTML thing, we have to link our scripts. Right? So player.js and
blob.js.
Blob.js.
Because that's what we called our enemies, blobs.
Blobs. Okay. Yeah. You can also if you notice, this is like the standard HTML. There's a CSS file with nothing in it, and this is standard JavaScript. You could do this in your own web editor. You just have to make sure to import the p5.js library. The reason why we're doing this,
sure.
Yeah, it's because it's built for p5.js, where like the preview and stuff more easily renders it. But you can do this in any web thing you want. It's just the same code that powers all the websites around there. Oh, look! There's our player. It can't do anything. It's a square. I figured before we move on, we should probably do some housekeeping things, like you might want to change the canvas instead of being a square to like a more wide thing, right? Something like that. That way, okay, that looks more like a runner, right?
Yes, that looks more like a runner.
All right. Now, if you notice in this thing right here, the Chrome Dino thing, it looks like the dinosaur is running forward, and then the rest of the world is there. What's actually happening? Well, the dinosaur is obviously running forward, but what's actually happening, like on the computer screen, is that the dinosaur is only moving up and down whenever you push jump. And the rest of the background is moving towards it. So keeping like the dinosaur in the same X coordinate essentially makes the programming a lot easier to do.
I agree.
Also, I feel like I'm obligated to keep going till I die now.
Oh, you'll die soon.
You can see my high score is not too terribly high on this computer. Oh, like there we go. Yeah. So we can go here. So whenever we jump, all we have to do is change the Y coordinate a little bit, right? So we can go here. We can make a new method called jump. There we go. Just like this. And we kind of want to introduce some velocity to it. So we're going to add a velocity variable. So this we'll call this vy, so the y velocity, and we'll just set it equal to 0 for now. So then when you push, when the object jumps, we just want to say this velocity, y velocity equals negative 22 or something. Actually,
TT says he's bad at the game too, and Kalen says the game is an illusion.
Oh, yeah, the game is completely fake. Let's go for like negative 10, just a nice simple thing. because as you remember, the y coordinates are like really weird. It's like they start from the top corner, they go down. It's like we want it to go up, so we're gonna set it equal to a negative thing.
Yes.
Right, and then we will make a move.
For some reason, it's inverted.
Yeah, it's really weird.
It's kind of confusing sometimes because you're so used to this whole coordinate plane when you're there introduced in math, and then here it's just flipped upside, or it's using the fourth quadrant instead of the first one. It's kind of weird sometimes.
Yeah,
it's really weird. Ow.
And then we'll make a simple move function. It'll just change this .y plus and we'll just add the velocity to it, right? So like whatever the velocity is, we'll add that in there. And then if we go to here in our sketch.js file, our main file, right? You can do player.show and then player.move right here. So every turn is going to move based on what the current velocity is. And then all we have to do is tell it to jump, right? So we're going to use a built-in function called key pressed right here, where basically every time a key is pressed, this function will be called. And we can say if key equals space right here, which will be our jump thing, then
is that how you do it here?
Player.jump, yeah. It's fairly simple.
It had to be like input dot spacebar or something like that.
Yeah, see, like that's how you would do it on like in like normal JavaScript, right? The point of like so the p5.js library just makes all this like so much easier. Oh, thank goodness. So we have this like key press thing right here, and if we do this and we push jump, it doesn't do anything.
Did you make a jump method in the player file?
I thought I did. So this .py, this move.
So if you made it there, then don't you have to give it the height? You have the momentum when it jumps, but it needs to reference something, doesn't it?
What do you mean?
So like right now you only have the jump, the vy, which is the velocity, right? Of when it jumps. But shouldn't you have something where like it needs to reference that object itself, like the height of it, in order to determine that jump?
Oh no, like this is just changing the velocity. Like the jump thing is just saying, hey, that we want the velocity to be like upwards, and then the move thing just like changes the object to move, like it tells it to move upwards.
Okay, I got you.
But why isn't this working? Good question. We have function draw, player show, player move. This is all right. Oh, I misspelled.
I just saw that the moment.
So the problem with built-in functions is that you misspelled them. They don't work. Oh, and as you can see, when we push jump, our thing jumps, but it never comes back down. So, but it jumps, and we have the function working well.
Be free.
Yeah.
Be free.
Unfortunately, we have to introduce some gravity, right? Now, if you're making an actual game, your gravity should probably be like some sort of global variable of sorts that applies to all the objects. But in this case, it only applies to the square, like the player object, so we can just make it a local variable. We'll say this equals 2 or something right here. So now, like whenever we jump, we set the velocity up really high, but then whenever we move, we also want to make it so that this the velocity will decrease based on what the gravity is. Okay, so we'll say this velocity plus equals maybe something like this gravity right here. So whenever the move thing is called, it'll be like, okay, hey, move the y, move the object up a little bit, and then decrease the amount that it's going to move up by next time. Yes. Right there. So now we go and push. Oh, it drops down because the gravity pulls it through the ground. We gotta fix that. Yeah, we're gonna use another built-in thing called constrain, and it's basically gonna limit the range that a number can be. So we're gonna say this.y equals constrain this.y. So we're constraining this.y, and we're constraining from the range of 0 to, and in this case we actually want, you would think we want height, but we actually want height minus this.size. Because remember, we have our box, and if we restrain the height, just to see, right here, it'll fall down. It'll, in the upper left hand corner, will stop at the bottom. But we want the full square to be visible. So we're going to stop it just like we're stopping a certain amount above. In this case, 50 pixels above, right here, and it stays right there. So now when we push spacebar to jump, it jumps. Although it's a very wimpy jump.
Endless jumper.
Oh yeah. Also,
we can beat the game like that, guys.
We can make. Yep. There we go. Look, you can just keep jumping like this.
Easy.
It's like Flappy Bird now.
Actually, it's not a bad idea to make it Flappy Bird.
So if you want, you can take this code right here. You can make a Flappy Bird game.
Yeah.
With probably less gravity and stuff. Mm-hmm. We might make that next week or something. Right?
That'd be cool.
That'd be cool. Flappy Bird game. But
Wednesday.
Yeah. Wednesday. Yeah.
Yeah. Also, let us know, guys. We decided to like step away from card games because we thought it was getting old. So we decided that we were gonna make some games like these. So let us know if you guys want more of these on the streams or videos on it. You know, maybe we could use Unity, right, to program these games. So let us know.
Some more visual games of sorts.
Yeah, because card games, they're just getting a little bit old. Yeah. Won't lie.
But yeah. Now we gotta fix our jump thing, though, right? It's like we have like this really wimpy jump. I think we should maybe increase this up to like a 20. Increase our jump, right? Okay, it still kind of sucks that the gravity is so big. If we change this down to like 1 or something. Oh, we gotta push run. There we go. Oh, that's a huge jump.
That's a huge jump.
Let's increase the gravity a little bit. Let's say we get here. It's a fair jump, right?
That's pretty decent. Yeah.
We can always
remember, guys. You could always just play around with the gravity and the jump itself. So
yeah. And also, like if you reduce your gravity, but you keep your if you reduce it like to like 0.5 or something, you get like a longer jump, right? So in the game, it would be a much wider jump compared to if you up your gravity right here. There's also a way to if you want to implement like push a down key or something, like a fall thing. Like if you're in like midair, you want the player to be able to like fall immediately down. You can just set the gravity to some like super huge number then and stuff.
Ethan Yang says hello.
Oh, hello, Ethan Yang.
Hopefully you guys are doing good.
Glad to have you here. We do have a small thing though, is that you can keep jumping forever like this, and you can just win the game without hitting any spikes whatsoever. So we have to make it so you can. Oh yeah, tax. Gotta make it so you can only jump when you're on the ground. Right? So we'll just do like a simple if, and then we could say if the height right is equal to this other height that we wanted right here, like so the upper left hand corner is where it's supposed to be, like on the bottom of the thing, right here. Then we can do our jump thing, and then if not, it just won't do anything. So now when we push play, we jump, and if we try to jump multiple times, it just jumps whenever we hit the ground, just like that. So now we can't fly over all the obstacles. So far so good, right?
Yeah.
All right. Sure. Let's get started working on our things that we don't want to touch, the blobs. So we'll call this blobs. We're gonna. I think we're gonna go with spikes or something, right? Should we go ahead and rename the spikes just for?
You can. I personally like blobs because it sounds silly. I like blobs.
Okay, we'll stick with blobs then. But right. these are our spikes that we're calling blobs. I know, not confusing at all. So we're starting with the same constructor, right? The constructor, the method is going to be called whenever we make a new blob. And what do we want for our new blob? We want a size, right?
Yes, for sure.
Something like that. And the thing is, because these are spikes, I think it'll actually be easier to reference the lower left-hand corner. Well, actually, let's just go with what we had for the player thing, right? We have our something like this, where we have this, and then we want since the blobs are going to be moving, we need a speed too. So let's say 5, something like that. All right. Then we need a show method, and we're just going to do the same thing as we did for the player thing, right? Just for now, even though they're supposed to be spikes, we'll represent them as squares right now, just to make it a little easier to program. And then the last thing we want is a move thing, right? A move method. And since these spikes have a constant velocity, it's not too hard. You just change the x value by or minus equals whatever the speed is, and that should work. Now we have to spawn in our. Well, let's check to make sure there's no errors. Okay, yeah. Now we have to spawn in our blobs, our spikes.
Yes.
Yeah.
So that will be in draw, right?
Yeah, it'll be in draw.
Yeah.
Right here. We're going to use a very, very simple spawning algorithm. Obviously, spawning algorithms, there's much better things, especially to increase the difficulty of the game as the game goes on. But for like testing's sake, we're going to go with a very simple one right now. Which we're just going to do a random for thingy. So if random, if we put 1, so it's a random number from 0 to 1. So any decimal number in between is less than 0.01. Then we want to spawn a new blob right here. So basically, every time the draw function is run, there's a 1% chance. And we can always tweak this number, or we can even write a better spawning algorithm. But we need to keep track of all the blobs in the game. So we can say let blobs equal open array. So this array will contain all the blobs in our game. And then in here, we want to say blobs dot push. So this is going to add something to the array. Blobs dot push, and then we want a new blob, just like that, right there.
That's a reference to the method, the object, right?
Yeah, yeah. So this is going to make a new blob. It's going to add it to the blobs array, so we can keep track of all the blobs in the game. And if we push, and whenever it does that, we can just like print like new blob or something right there, and it says new blob, new blob, new blob. Woo! Okay, but it doesn't actually do anything because we can't see the blobs. So instead of printing new blob, we're going to have every time the draw function runs, we're going to display the blobs and move them over a little bit. Right. So for we want b a certain variable. So for blob, I guess blob of blobs. So for every blob in the blobs array, it is go. Oh my god! Why do we have to stick with blobs? So for every blob of the blob array, we're going to do whatever's in this for loop right here. This is a for each loop, and we want to simply move the blob like this, and then we want to show the blob like this right here. Exactly. So now if we push run, wait, as you can see, they're spawning in, but they have to be spawning in from where the player is. So we actually want the x coordinate of where the blob's going to start. So yeah, this x coordinate right here, this is our starting x coordinate. We want it to be the width of the screen right here. So like the whole with the rightmost side right here. So when we push run right here, it spawns in. Woo! And oh wait, okay, there we go. Spawns in. We can jump over them.
The blobs are the players' brothers.
Oh my! I don't know how this that codes with the So yeah, we have this
simple spawning algorithm.
Yeah, as you can see, it's a little hard to jump over the blobs. Obviously you can collide with them. We haven't added collision detection yet. Maybe we should try to make the jumping a little more to make it easier to jump over.
Okay, fair enough.
So that way, because right now it's a little hard to jump. Oh, there. Okay, that's a much bigger jump. Whoa! Hey! Oh, what's a? Or really, it'd make it even easier to jump over the blobs if the blobs moves faster.
That is true.
I think we need to up the speed of the blobs a little. Maybe we up it to 8 or something. Let's see how fast these blobs are coming. Oh, there we go. Whoa! Whoa!
Hey, that's about the same speed as the dinosaur game.
Yeah. As you guys can see, our spawning algorithm has a few problems. Most notably that it's very inconsistent with spawning. But
there's one major problem.
Oh, that's you can't collide.
Yes.
Yeah. Now the thing is, before we add the collision detection, we actually have to.
TT says using no clip cheaters. Kaylin says these guys are always cheating.
What? I don't know what you're talking about.
I don't know what you're talking about.
Maybe for one live stream we can show them how to actually cheat in games. But yeah.
That's a good one.
But before we can do that, we actually have to worry about one thing, that we should make our spikes look like spikes. And then we can collide with the spikes. Otherwise, we're colliding with boxes around the spikes, and it's a terrible disaster. Yeah. So in order to do that, we're actually going to use the triangle thing. So right now we're making a rectangle with the coordinates, and instead we're going to make a triangle with. But the thing with the triangle thing is you need all 3 coordinates, right? So we're gonna keep this line right here, but let's comment it out so we can, or use this reference. So we want the lower left-hand corner of the triangle, right? Which would be this dot x, right? It'll be the x, and then the y will be the height, essentially, right there. And the next point, the peak point, will be, let's say this dot x plus half of size, right? So size divided by 2, just like that. But that's going halfway over. It's not an equilateral triangle is a little harder to make, so I think the isosceles triangle should be also sufficient, right?
Yeah, for sure.
Yeah. And then that would be the peak of the thing. So we'll go for this dot y. That's the y coordinate of it. And then the last point, the lower right hand corner point, is going to be this dot x plus size and the height again. I think that should work. Hopefully, if we push run, you can see that we get these have to be this dot size, not this size. Okay, now if we push run, we get there they are. Okay. As you can see, some more problems with the spawning algorithm, but it looks to be pretty good so far, I think, right? Like, we have the spikes in here. Now we're gonna do some collision detection, right? And thank goodness there is a nice fancy library we can use for collision detection called the p5 collide 2D library. And here, if we open it up on GitHub, and as you can see, if we scroll down here, there's lots and lots of 2D collision detection things. And unfortunately, there's no colliding with rectangle and triangle, which is what we have here. There is a collide rectangle, which is what you would mostly expect for a lot of things. For like, if you have this rectangle here, there's a rectangle around a triangle, and it sees if they intersect. But that that wouldn't really work because people would complain about how the hitboxes are completely unfair, right? Because the hitbox it can extend quite far outside of the triangle. So we will, I think, instead be using the collide line rectangle right here, where it's basically seeing if a line and a rectangle are colliding. We give the line, we give the rectangle, and then it tells us true or false. But in order to use this library, we have to import it. So we're going to use this thing called JS deliver, spelled with an R at the end, right here. And basically, what we can do is we could take any JavaScript file in the GitHub thing and import it into our project as a library, essentially, a CDN. So we're going to copy this basic sample text right here, go to our HTML file. So we need to import a new script file. So script equals, and then we will feed in the link, and then we will close it, and we will close the tag. Just like that. Now in here, we're actually going to have to feed in the what file we want. So as you can see up here, we want the username of the person who made it is bmoren there, and the thing we want is p5.collide2d. I hope I spelled that right. Yeah. We want, or the file we want is, let's go here and scroll up. We want to grab this file right here, right? Which is the JS file. It's also the minified version, which means there's no spaces in there, but yeah, that's our file right there. And now push run, no errors. Okay. And just to verify that we have this installed, if we go down to line rectangle, that's what we want. Yeah, line rectangle right here, and we just copy this code in. So we're making a method call in our thing, and we're just trying to see if we imported the library successfully. We push run. Yeah, we have, because it works. So now we got to see if they're colliding, right?
Mm-hmm.
So now in here we can do a for every blob we want to run a thing that says if it's hit, right?
If it hits the player, or if the player hits the blob or spike, I guess.
Yeah. So if they're colliding, right?
Yeah.
So if we could do like if player dot hits, and then we feed in the blob. So we're giving the blob's coordinates to the player object, and then if it hits it, then it'll return true. And if it does that, and we can print game over.
TC says too many spikes, game rigged.
What? I think we left it as an exercise for the viewer to implement a better spawning algorithm. And also, what we're just gonna do for now is we're just gonna do a no loop thing, which basically is a tells the program in the p5.js to stop running, just like that. But now we have to make our hits thing, right? So we gotta go here to our player file, and we gotta make a hits method. So we're gonna have something like this, right? Where we have our method, and we're gonna take in a blob as a parameter. So now that we have this, we need to see if they are colliding, and we're gonna use that method right here. So collide line rectangle. So the first one is the line. We want to first check to see this front line of the rectangle right here, or not the rectangle, the triangle. My bad. See if the front line of that triangle is colliding. Now remember the coordinates to get the front line to the right of the triangle. It's this dot x, and the height, and then all the way to this dot x, and this dot plus this dot size divided by 2, and this dot y. So this is our line for the first side of the triangle. Hopefully that works. Boom. And then chappal. And then we want our rectangle coordinates, right? Just happened, or we want the upper left-hand corner of the rectangle and the dimensions of the rectangle. So that just happens to be these ones right here. We can copy and paste that into here. And then if this is true, we want it to return true, and if it's not, false. We add a return statement up there. All right. Hopefully this works. No!
Is it because it's the same object, do you think? Because you have it... Oh, no, that doesn't make sense.
Something messed up with the coordinates, I think. So, we're starting with, okay, this.x. Oh, it needs to be blob.x, that's why.
Yeah, that's okay, yeah, that's what I thought.
Yeah, so, all of this is in the first part. They're referring, to the thing, that's why it's all colliding. Okay, so, 1... Ooh. That should be right? The last one's okay. It should be this.
Yeah, because the last one's the actual rectangle.
All right, let's try this. Jump. Oh, jump. Okay, let's. Oh, see, look, we collided. It says game over. I think that's pretty good, right?
Pretty decent, yeah. That's pretty good.
It collides here. I don't know what the odds are that someone's going to collide in the backside if the things are moving fast enough.
That's true.
I think the front side collision is pretty good, right?
Oh, for sure.
Yeah. So, jump. Oh, my. Wait, I pressed spacebar. This game's rigged.
Even though you're the one that made it. Okay.
Yeah. There's one thing.
Blame it on the lag. Blame it on the lag.
Yeah, it's so laggy. It's because it's the online editor. That's why. Speaking of problems with coding and lagging and stuff, as you can see, after the triangles go off screen, they still exist and they keep going off screen. And what's going to happen is that it's going to cause a significant memory problem if unless the program's smart enough to automatically get rid of them. But we're assuming that there's a potential memory loss problem if you keep running the program and there like more and more spikes appear off screen and it builds up. Could be a big problem. So we need to get rid of the spikes that appear off screen, right? So as it cycles through each blob, we're going to make a quick check to see if the if it's off screen. So if the blob dot... Oh, we can't do X. We got to make a method to get X. Since these are, I think they're private variables.
I believe so.
I'm pretty sure they are. Because like that's why we had to use the this thing. We're making a method. All it does is give us the return this.x. It just returns the this.x thing or wherever it's currently located, right? We go back to here, and then if blob.get x right here, and say if it's less than 0, so that means to the left of the screen, then we want to remove it from the array. And in order to do this, because the thing that appears to the left screen is always going to be the first thing in the array, we're just going to do a blobs dot shift right there, which will just give it the first thing in the array and shift the start of the array over to what the second thing is, just like that, right?
Put a print statement so that we know that it got.
Oh yeah, because we can't tell if it if it does anything. We'll just say remove like that. Oh look, see, it removed those two.
Removed.
Yeah, so it's
removed.
Just taking those out right there every time it gets. Oh, there we go. You can also kind of see it like it happening. Like, oh my, okay. If I can get past the first spike, once it touches the left boundary, it kind of disappears. Like, a little sooner than we would like it to actually in practicality, right? Maybe like we want it to disappear after like -50, so the whole thing's off screen, right?
Yeah.
Yeah, but you can see it works right here because like it obviously disappears. I think one of the final things to add is the score.
I believe so.
Yeah. Because what's the fun of a runner, if you can't compete with your friends?
Exactly.
Yeah, so we'll set a score to equal to 0, and then we want to increment the score by some amount. Let's just say 1 for now. So 1 per draw thing right here. And then
you gotta print that text out to the screen.
Yeah, so we're gonna use a texting, and we're gonna say score, and we want to print it at say 10 or 30 or something like that. We want to print score at the coordinates and at 10:30 right there. And if we push run, as you can see, it increases right there. It's a little small. We can make that bigger with like text size, say like 30. 30? Okay, 30. Right here. Also, you might notice JavaScript, it's semicolon optional. Unless you're me, always gotta semicolon. Always gotta have semicolons. Except when you don't need them. But yeah, now if we push run, we can, I think, maybe move down a little bit.
Yeah, just a little bit.
Just a tiny bit right there. Just like that, right? Like,
yeah, that's pretty decent.
Yeah. So now there's a small problem where, well, it's not necessarily a problem, depending on how you look at it. But the score increases very, very, very rapidly.
I mean, technically, the score is the score, regardless. It's relative to how long you've stayed there.
Yeah,
but
sure.
We want it to be more presentive.
Yeah,
right?
So because like when you play this, right, you don't want to see like 5 million things. You want like a nice score you can tell people about. So we're gonna increment it by a little bit. Let's do like round score. Oh, whatever. So it increments it by much less. Look at that.
There it is. I mean, technically it's the same thing, but the value is greater. But technically it's the same thing.
Yeah.
But I do like this better. And you.
And nice. I died.
Nice.
Yeah, yeah.
But I mean, that's the game, isn't it?
Yeah, I think that's the game. Obviously, Josh and I are we are not artists, right? The most we can do is like use this fill command, which will turn everything blue. So that this is blue, all the stuff is blue. Oh my!
See, that looks cool.
I'm
a blue person. My favorite color is blue, so I like that. That looks cool.
What if we like change like the player right here? So like when it shows, it like fills to I don't know, like lots of red or something. Oh, look at that!
That's a pink color. That's cool. And then we have.
Oh, it makes everything else pink. Oh, shoot. Let us copy this into the blob thing. Okay. So when it prints the blobs, it prints them as blue, and when it does this, hopefully it works. Yeah. So now we have blue blobs and we have pink squares. So the pink square is trying to. Oh, can we do? Oh.
You cannot jump that over. Kaylin says that's nice.
It's not the best color combination in the world, but you know, essentially you can. Okay, this is terrible.
Come on, man.
We gotta make a better spotting algorithm. So, ideas for like spotting algorithms that we kind of brainstorming. You can have it so that it like there's like fixed spawn points. And there's a percentage of spotting in each spawn point. Also make it so that like oh, you know, it'd be really easy.
TT says, I don't think that jump is possible. The game is rigged.
Yeah, it is definitely rigged. What if after it spawns in the new thing, there's like a cooldown timer of sorts before it can spawn in another spike?
So you wanted to delay it even more?
No, like there's a cooldown time. It's that we can increase the spawn rate spikes, but like there's a cooldown timer after a spike spawns.
But delay when it comes out. Okay.
Yes, like it spawns in and it's like, hey, you can't spawn another spike for the next like however many seconds or something.
Like 2 or 1 second. That's smart. Maybe we could do that. That would make sense.
So like let's see how like after a spike spawn it takes like oh my. Oh look, I got to jump over that. So let's say like
1 second is fine.
1 second, like in score units, that's like three score units or something, right?
Yeah.
Okay. How should we? What if we had like a minimum score unit to spawn the spike?
Like so a minimum of like two scores.
Yeah, so like whenever it spawns in this a spike, it says the minimum score to spawn in a new spike is score plus 2 or something.
Mm-hmm.
So that way, and then it checks to see if the score is above that, then it spawns in a new one.
Yeah, I like that idea.
Oh, min score, I guess equals 0, right here, and it's whenever it spawns the new one, we say min score equals score plus 2. Let's try that, right? And then if score is greater than min... No, whoa. We gotta spawn in the blob first. Now, if score is greater than min score, then we want to spawn in the blob. Right?
Yes.
And then else we want to increment this. This could have been very bad if we did not put the else thing in there. Because then it would like increment the min score by 2 like every time, and the score would never be higher.
Output. Mm-hmm.
Now hopefully we fixed our... Okay. Ah!
I can't tell if it did or not.
I don't think we have any that are like super close. I mean, except they're kind of close. Maybe we should increase it to like 3. Oh. Uh-huh.
That's not bad, actually.
Oh, that was kind of close.
Frame perfect jumps pogs, says Caitlin. Okay.
Oh.
Adam going professional.
Uh-huh.
Says TT.
Oh my god!
Oh, nah, bro. Come on.
Okay. What happened here? I have no idea what happened here. What?
It all came at once. I don't think it was working, man.
I don't know, but like it worked for like 117 things, and then I got to.
What? Says game rigged. Galen says laugh out loud. I think. Why don't you? We get the time. We wanted to put it at a set amount of time. Can't you like make it instead of doing the whole time thing? Can't you put it to .sleep and then do it?
Oh, like just wait.
Yeah, like.
Oh.
I don't know, like 500 milliseconds or something.
But won't .sleep like stop everything else too?
No, that would just do the spawning. It would just be the spawning. If you do it in the if score greater than, you could just do right under the if random thing. You could do thread.sleep for like 500 milliseconds.
Wait, well,
or I don't know what it is in JavaScript.
Oh, what .sleep or?
I have no idea. Let me check.
There's a delay time.
Delay time.
Yeah, this is like a delay time thing. So it's just the delay time and then 1.
I don't know how it works in.
It's
not defined. Yeah, I figured. Okay. Let's see. Is there like a class, a method?
Oh, it's just something else. Just out of curiosity, I want to see what happens if we try to spawn in them. Oh, okay, it does not work.
Whoa.
So wait. Okay. Oh, we're idiots. We're such idiots.
What's going on?
We increase the bit score if it spawns in something.
Oh.
We're such idiots. Oh my god. So this is every 3 things. Right here. This is the distance for three things.
But it's not really random anymore, is it?
Yeah, I know. I upped it to the maximum thing. So if we reduce this to 1.5, half of that, then it's oh my, that's way too much. There we go.
What? You should have died there. I'll be honest with you. You should have died there.
Hacks. There we go. Much more enjoyable experience, right?
Much better.
All right. Okay, so the small problem here right now with the collision detection is that we don't the thing has moved, but it hasn't shown that it's moved, and so it has collided, but it's barely skimmed it. Okay, that's not too bad, right?
Yeah, it's actually really great.
We can actually increase the speed as well.
Of the blobs, yeah. Yeah, we can.
Should we try doing that?
Try it. I mean, this is where you can customize your own game, what you want to do, right?
Yeah.
Maybe you could put it when it reaches maybe where you stop, maybe at 50. Every 50 time limits, or 25, we can
increase the
speed. Yeah, by +2 or +3 or something.
Yeah, so there's lots of different you can also do a bunch of different functions and stuff. You want a function to it increases the speed, but it doesn't because there comes a certain point where it becomes impossible, right?
Yeah.
I think we'll just have maybe we up speed and then we give it or let's just do set speed right here, and it would be equal to speed, and we'll see this dot speed equals speed, like that, right?
Mm-hmm.
So when we go here, we can say, okay, as it's going along, we want to set speed. Oh, whoa. Wait a minute. How do we do a static variable or a static? Can this even be done with static variable?
I have no idea how to do that.
Okay, well, we got this. For each blob, we're going to set the speed. Oh, this is probably not the best way to do this, but I think it'll work. We can set the speed equal to 8 plus some small. Let's see. Can we do a square root, maybe? Oh, there's a square root function. Yeah. Square root of time, or of score. Divided by, score. Okay. Like that, right? Hopefully that. Why is it giving us an error? Oh, we need another. Whoa! Okay. Now. Ah! Shh. No one saw that. So we're setting the speed of the blob, right? We can't just say set speed. We have to set the speed of each individual blob. That's what's going on. So we have it's a little faster. We're not getting any. There we go. There we go.
There you go. Now it's definitely faster. Whoa, dude. But it's spawning less now.
Yeah, so I think we need to decrease the spot, like the speeding up thing by like a lot.
Sure.
So at this point, like we're just like optimizing the game, right? We're trying to get more see, now just like now it's spawning too consistently, right?
Mm-hmm.
What if we decrease? What if we kept this like this a little bit, and then we added to this a random number thing?
Okay.
Like that. So like the distance between them was like more random-ish. So right now we have a long one.
There we go.
There we go. Can you feel the game speeding up?
Not yet.
I can't really feel the game speeding up. Let's see. It would have increased by. Okay, once we get to, I think. Oh my, yeah, it's not gonna have speed. It's not gonna speed up that much. Let's because right now, if we stop right now, right, like, or let's say stop right. Okay, we stopped at 120, around 121. The square root of that was 11. 11 over 25 is like less than half, so it's like 8 point like less than half.
Yeah.
Why don't we bump this up to like 5? And then we can print. All this right here. That should work, right?
Mm-hmm.
So push run. Okay, we're at 8 point. Oh, we're speeding up already. Ooh. A little bit of lag from all the print statements down there.
Yeah.
Okay, but it is speeding up though, right?
It is slowly.
That's I think that's a better speeding up rate. Okay, boom. There we go. Now we don't have those print statements.
TT says 5-head math.
5-head math. Oh! Is he teasing me for like not being able to do like 11 out of 25, which is point 44.
I didn't even know that. So you know what? I'll let you have that victory. So.
Oh man, I can't remember.
There you go.
There we go. But look at that. So it's
but we basically finished the game. It's just now we're tweaking the logic and customizing it to what we like.
So it speeds up.
You guys could do that too in any game or any program, really, any software. Customize it to what you think is best. Optimize it. That's what the features are for, right?
Yeah.
But I think that's it. I think, I guess if you guys have questions about the thing or future things, while Adam tries to beat his previous score of 170, I think it was.
I think it's going pretty good. I mean, this is so much better than the Chrome Dino game, right? Like, you got like pink squares, blue triangles. What else could you want?
Artistic value.
Oh yeah, that too. I mean, we don't have a background or anything, but like it's
I think that's a little too easy.
It might be a little too easy.
Difficult.
One of the hard, yeah. One of the hard things about the Chrome Dino game is like the birds that come. The birds are what get you.
I think my highest score there was 2,500 or 700.
You have to stand out there and saw my terrible high score. Just you know, that's only on this computer, okay? Like 14,000 or 1,444. Oh, we passed pi. That's 100. Yeah, are there any questions and comments about this, or you guys want to see next? Oh, birds. Oh.
Wow.
That's unfortunate. Well, I guess that's it.
I don't see any questions. I think we can call it.
Yeah.
Yeah.
Just past
So,
exactly now.
anything we have to say? Any announcements?
Uh,
Besides the fact that if you guys want more of these games, just let us know. We could probably do them in Unity, which has its own syntax, but it's similar to C#, so it's basically OOP. What else? What videos they want to see more of? I
yeah.
guess. Right.
Uh-huh.
Scratch video.
What? Is there a comment saying scratch video?
TT says he wants a scratch video.
A scratch video?
Can I ask why? Like, to be quite honest with you, why? Why do you want a scratch video? Look. There's nothing wrong with it, you know? There's nothing wrong with Scratch. It's a good beginning language to start out programming, but
You know, we
it's
could make
just,
the runner in Scratch.
but it's just, I don't know. Okay, I guess maybe it's just me, because obviously everybody else is okay with it, but maybe it's just me because you don't want to. Is that why you want the Scratch? So that's why you want the Scratch video.
You're Josh's frustration.
No, see, because the thing is with Scratch, it's just blocks, and it's I don't know. To me, it's just very confusing how to use it instead of just easily doing. Maybe because I'm used to like just coding like this, but I remember seeing like if-else statements that they were straight up blocks connecting to each other, and it's like, what? I don't know. Like I said, maybe it's me because it seems like everybody else is all right with it, even Adam.
What?
So
Oh
like,
well, I mean, it's good for the visuals. Like with this thing's like really nice for visuals, but like in Scratch is good, but like it takes so much time to find the stuff that you want.
yeah,
You're like, I want a for loop. Where is that?
the
Okay,
building blocks of life. That's what Kalen said.
Oh, I don't know if you guys have heard of the game of life.
The game of life.
Not the board game. Not the board game one, but the game of life. Is this one? Yes.
What is this? What am I looking at?
So like, there's pixels on there.
The Oregon Trail.
No. There's pixels on there. The yellow ones are alive. The gray ones are dead.
Oh, well, that's dark.
If each alive cell has one or less neighbors, so 1 or 0 neighbors, it dies out of solitude and sadness.
Oh my god!
It's alright.
Wow. That's dark, man.
Yeah. If it has 4 or more neighbors, it dies by overpopulation. And if it has 2 or 3 neighbors, it survives. So, and each cell with 3 neighbors becomes populated. But yeah, it's kind of.
That sounds annoying.
But what happens is that you can see how it morphs. It changes as the thing goes on.
What the?
So like, because of how the rules work, what you can get is you can get something like a glider, right?
TT says make some encrypt and decrypt program. Now we're talking.
We can do that.
Now we're talking. Because here's the thing. Like, a while ago, I made a password cracker. Don't ask why. I made a password cracker. And it was really interesting how the logic of it works. Right? I didn't use libraries or anything. I straight up did it from scratch. But it's very interesting how it works. I think that's a great idea for, I don't know, stream or a video. What do you think? Suspicious. Look, TT. Look. It was just me. I wanted to learn encryption because encryption to me is kind of, it's interesting. Like, you know how in movies when they're all hacking, they're like, oh, I'm in, kind of thing, right? I always wanted to learn the whole. I want to know how you got in. I want to know like that part. Okay, so I didn't use it for anything other than just testing purposes.
Yeah. Besides, there's much of protection they have.
But yeah, there's also the hashing, and then there's the salting, and then there's
Josh, you see what's going on?
And while I'm talking, there's like a whole war going over there. I don't know what's happening over there. It's like shooting some missiles or something. But
yes, game of life.
So encryption, decryption, I like it. I'm down to do that. I don't know if you want to make it a stream or a video. I would definitely be like, but I cannot speak. I would be down to make a video on it if you guys want that. I'll make it in Python because Python. I really like Python. I don't know if you guys know this. I like Python. But yeah, I am down to do that. But other than that, I don't know if you guys want more games like these, more mini games like this. Maybe Adam and I can like make a collaboration playlist where we can, make a game.
Yeah, we can have like a long ongoing series.
Like a full-fledged project.
You will see our terrible art skills.
Yeah.
But yeah, maybe like a few weeks, a few months, maybe. Mm-hmm. I don't know how long it'd take us to make one. Oh my.
Okay, Adam, can you explain what is going on?
Okay. So
what is going on?
Do you remember how we had like the rules that caused the things to change, right?
Yeah.
So like this thing right here, it's set up in such a way where like it goes back and forth and it spawns out these new things that come out.
Wow.
And so these new things, like they're configured so that they can glide indefinitely off the screen. But obviously this is like a gun type thing where like it's like shooting, right?
Yeah.
But you could also use stuff like this as like electrical pulses, and there you can have a simulation of a computer in this simulation.
What?
Yeah.
Wait, what? What do you mean? You just confused me.
So like, let's see, John Conway's game
either streamer video. Yeah, like I said, we could I could do a video for sure. I could do that as I don't know, like 3 parts, because it took me a while, mainly because I didn't know what I was doing. But yeah, I could do a video or stream, whatever you guys want. What is that? I thought that was a logo for a second.
This is the same thing we saw, except it has like the memory right here. This is the program. That's the printer down there, and each one of these is like those are the little tiny like spaceships flying at each other. Right there. So like you could see like the little tiny spaceships that were coming, and they're going through the program.
I'm gonna be honest with you, Adam. All I see are dots.
Yeah.
Oh, they're the thingies.
They're the thingies. See, the gun thingies are coming from like the up left hand corner, like the signal's coming in, and then like it's like doing the calculations with like the AND OR gate stuff. And I don't know how any of this works, but
that's actually crazy.
So, yeah, I thought it was kind of. We're not recreating this.
No. So yeah, I think that's it, right?
Yeah, I think that's it.
All right then. So encryption, decryption video or stream, I am down for.
Yep,
for sure. Maybe we can make a collaboration series, me and you. On programming a game. I'd be down for that too.
That'd be really fun.
Because I'm basically done with my learning Python videos. I just need one more, and then that will be it. I don't know about you for your Java.
We still got like quite a few like classes and all the fun Java stuff.
Polymorphism.
And inheritance and interfaces and generics and all that fun stuff. Because like it's not all default like Python.
Yeah, that's the best part about Python. You want to import a class? Yeah, no problem. Just import.
You want to make a generic?
Extends. You don't have to do the whole inherits from, extends to this, gets the object.
Which method does it call? Does it call this method? Does it call the parent method? The child
constructor have specific like overflow. Yeah.
But
gotta love Java.
But hey, it could be much more efficient at times.
Yeah, oh yeah, for sure.
Which is like yeah, for those of you guys who are like, oh, what should like C++ much harder than Java and Python, but like way more efficient, runs way better.
Yeah. Okay, I think we can end it here.
Yeah. All right. Well, thank you all very much for joining us. It's been a pleasure having you all.
For sure. Yeah, we'll see you guys later Wednesday.
Yes.
What will we do Wednesday?
I don't know. We will figure out what we're doing Wednesday.
We will figure that out. All right, cool. So we'll see you guys there Wednesday at 4 p.m. Central Standard Time. And yeah, that'll be it. All right. Hopefully you guys have a good day.
All right. Take care.
All right. Goodbye, everybody.
All right. I pushed